In this problem, we have 18.6 grams of calcium chloride being reacted with 54.2 grams of magnesium nitrate. The product is calcium nitrate and magnesium chloride. We are being asked, what is the limiting reactant, how many grams of magnesium chloride will be produced, and how many grams of excess are left over. As always, we start with a balanced chemical equation, which is CaCl2, calcium chloride, plus magnesium nitrate, which is MgNO3, reacting to form calcium nitrate, CaNO3, plus magnesium chloride, MgCl2. When we look at this equation, it's already balanced, so all of the coefficients are 1. In limiting reactant problems, we are given two starting numbers, and we have to change those starting amounts in those substances and compare them in the same substance. So for example, we can't compare calcium chloride straight to magnesium nitrate. We have to change them both into calcium nitrate or magnesium chloride, whichever one we decide. Now, because one of the questions is asking about magnesium chloride, MgCl2, it makes the most sense to do that as our comparison. So we start with our first starting number, 18.6 grams of the CaCl2, and we're going to convert it from grams of CaCl2 into moles of MgCl2. And so when we use our mole roadmap, we're going from grams of A to moles of A to moles of B. To do that, we take the molar mass of CaCl2, add it up off the periodic table, which is 111.1 grams, and then put 1 mole on top. Then to convert from moles of CaCl2, we want to go to moles of the MgCl2. We use the coefficients, and since everything is a 1, we put 1s in both places, and then we can do our math. When we do this math, 18.6 times 1 divided by 111.1 times 1 divided by 1, we get 0.167 moles of MgCl2. Now we have to repeat that process starting with our other starting amount, 54.2 grams of the MgNO3, and we're converting it to get, again, moles of MgCl2, so we can compare substances that have the same units. To do that, we use the molar mass of the magnesium nitrate, which is 148.3 grams per 1 mole, and then we convert magnesium nitrate, MgNO3, moles of it, to moles of magnesium chloride. And when we look at the coefficients, they're 1, so it's a 1-to-1 relationship. Then we can do this math, and when we do 54.2 times 1 divided by 148.3 times 1 divided by 1, we get 0.365 moles of MgCl2. To determine the limiting reactant, we look at these two answers, 0.167 moles of magnesium chloride and 0.365 moles of magnesium chloride, and we see that 0.167 is smaller. So when we go to the starting substance there, we see that CaCl2 is our limiting reactant, which means that the magnesium nitrate is our excess. For the second question that we're being asked, how many grams of magnesium chloride will be produced, we always base our answers for these additional questions off of the limiting reactant. So starting with the 18.6 grams of calcium chloride, we've already converted and found 0.167 moles of MgCl2 can be made, but it's asking it for this answer in grams, so we're going to take the 0.167 moles of MgCl2, and we just have to go from moles to grams to get our second answer. To do this math, following the mole roadmap, we're going from moles to grams. 1 mole goes on the bottom, and the molar mass of MgCl2 goes on top, which is 95.3 grams. When you take 0.167 and multiply it times 95.3 divided by 1, we get 15.9 grams of MgCl2, which is our second answer. The final question is asking about the grams of excess left over. Now we know that magnesium nitrate is our excess. So to figure out how much is left over, we need to know how much do we start with, and we also need to know how much is used. I think it's easiest to do your conversions and get your mole values and then convert to grams at the very end if necessary. So we know to figure out how much that we started with, we know we had 54.2 grams of the MgNO3 to start off with. And when we change that grams to moles of MgNO3, we just have to use the molar mass. And so we know the molar mass is already 148.3 grams. So when we do that math, we get 0.365 moles of MgNO3 to start with. Then we have to figure out how much is used. And whenever we figure out how much is used, we always have to use the limiting reactant as our starting number. So we take the 18.6 grams of the CaCl2. We got to change it to moles first. So 1 mole of CaCl2, the molar mass is 111.1. And then we'll do a mole to mole ratio, moles of CaCl2 to moles of MgNO3, and that's all 1 to 1. So when we get that, we know we have 0.167 moles of our MgNO3 that was used. And so if we want to find out how much is left over, we take our starting amount, we subtract the amount that was used, and we would get 0.198 moles is left over. But the question was asking for this number in grams, so we'll take the 198 moles of our MgNO3, and we will just do a one-step conversion from moles to grams using our molar mass. And our molar mass of magnesium nitrate is 148.3. So when we do 0.198 times 148.3 divided by 1, we get 29.4 grams as our final leftover answer. 29.4.